We got another little project, and this one's not going to be as easy. It's our furnace. So this here is a boiler that we got put in when we had built the house in '01, and I like this boiler. It's really good and efficient and works great. But I put that in there because this fell down on my head once. Twice. So anyway, you can see how nasty that thing looks. Now again, it's our water quality. Our water quality is not that good, and it's hard on things. So I've already had changed these over to brass before. A lot of this is actually just things that are leaking down in. It cleans up pretty good, but you have these relays. Look what happened here. So that tells me back inside here, there are, I think this thing has 5. Yeah. Has 5 elements in there, heating elements, with 3 relays. So what happened is it's rusted out and it's shorted out, and so it's drawn a lot, so it's burnt out. This happened one other time, and I took everything apart, put all new heating elements in it, and I put those relays in too, because those relays, after a while of coming on and off, clicking, they spark almost every time. In those contacts, they'll actually start to spark, and I could actually hear it when it turns on. I'll hear the little brrr kind of a noise. But this is a simple system. It's really nice because what it does is one relay clicks and 2 elements come on, and then there's a timer, and then about like 30 seconds later a second relay clicks, and then another 2 sets of elements come on, and then if it's still calling for heat, the third relay will come on, and then the last one will be the last element will come on. So it really doesn't kill your electric bill all at once by coming on and making a big voltage spike. So anyway, I like the system, but it's been in here since '01. I hate to change it. I can still get the parts, but you can see how rusty those bolts are. I think we're going to be fortunate if we can get these back out again. So let's do the first things first. Let's turn the power off. So here's my boiler system. It's on a 125 amp breaker. Got to shut that off. But also highlighted in pink here, it says boiler thermostat. So I got to shut that 15 amp breaker off too, because that's the thermostats. They just put XFMR. It didn't mean nothing to me. So I made it easy. Put Sharpie or pink marks on there. The highlighter. I know exactly what it is that I'm going to be messing with here. We should be good to go now, but just to be sure. Ah, see that one? It melted that wire. It tripped that breaker. But the breaker still feels okay. All right, I don't have any coil, unfortunately, but I do have PB Blaster. So well, that one ain't too bad there. That'll probably come off. So we're gonna spray that down, let that set, come back another day here, and go ahead and see if we can't tear this thing all apart. It should be fun. Well, it's that time. I'm gonna actually conquer the furnace, or at least I hope so. We put some of that PB Blaster on the bolts back there and over here. So now I'm gonna try to take this cover off. This whole blue cover should come off. So let's see how that part goes. Got bolts up there and probably sides and below. All right, let me struggle with this for a second. So there's little All right, I cheated. I got a little rough with it. I pried it down. I can bend it back. Yeah. Guess the big question is this thing worth salvaging? I mean, it's a cast iron tank. It's all the surface, really. There's those bolts that I'm talking about. So we've got water in here. So I got extra lines here. This one, yeah, this one and this one. See, they run out to a circulating pump, and then those go out actually to my garage. So my original plan was I had a wood burner out there, and I made a grid. It went on top of the wood burner. I was actually able to heat the water, and then it could come back in and heat the house, but it just didn't quite keep up enough. I needed a little more, so it would actually drop a little bit in temperature throughout the day, and rust everywhere. And so that didn't quite work as well as I wanted to, and I really had the opportunity to fix it properly. So it's just a plastic cover. It scared me. So I gave up on that, but I could always add a register out there if I want to. So we do have a shut-off valve here for the water, but we never put one in down here, which was pretty stupid. I don't know why there's none in there. I actually put one up here because I've had to change this tank numerous times. You see that's just leaking. It looks like it's leaking anyway, but it's from that valve up top. That's actually an air bleeder up there that'll automatically bleed out air out of the system. And so that's actually quite normal. But this has a fiberglass liner in it because the water was actually rotting the tank out, and it would leak right around that bead right there, because this is a bladder tank. And so it has air in this chamber, water in this chamber. As the water expands and contracts from temperature change, as the temperature goes up, it expands. So it has to go somewhere. So it goes inside here, pushes that bladder down. That way you always keep constant pressure on your tank there. Anyhow, that all worked pretty good. So I got this shut off. This is your pop-off valve. I can drain this if I get a hose. I can drain all of this water down. Unfortunately, I'm going to have to. I really do need to put another shut-off valve in this system so I don't have to do this again and again. So I'm going to get a hose and hooked up and start draining out the water out of this system and cleaning stuff up. So I connected a hose here, and I also opened up the T&P valve, and yuck, rusty. I got that hose going over to a bathtub, so our pressure's down, but it's going to take a few minutes for this thing to drain down, because it's not a ton of water, but there's enough in there that it'll take a few minutes. So let this drain down, and I guess I can start. Must have put insulation to keep it off of these wires because it's right up against the furnace here. The electrician did this. Wasn't me. But what I'm really wondering is how are those going to come off? This side doesn't look as bad as the other side. I got a little wire brush. Well, I don't need to take that one off. I gotta get this one off. This side looks good. Start maybe seeing how that one works first. Okay, a couple things we're gonna have to move out of the way first. We've got this here transformer. Gotta get that at least out of the way, and we'll go from there. But as you can see, those bolts, they're very rusty. So get you guys set up here. Hopefully you can see. For something that seems like it's out in the open, not a lot of room to work. And this one back here is really buried. If they could have this metal plate come off, then it would be so much easier. One screwdriver is too long and the other's too short. Transformer's hitting the handle of that screwdriver. And this next size up is a little bit too long. If that was slotted, which guess what? It may be slotted next time. I've got to put it on. Then you don't have to take the bolt the whole way out. You can just loosen it. That's why they pay the engineers the big bucks. That'd be nice. So I was looking at the wiring on this, the ones that melted. there was those two black wires that melted off of the relay, and they go to the two top little heaters. So those are probably the ones that are shorted out. Oh, that thing's a mile long. All right. So what do we want to call that top one? What thermostat, or I mean, wiring here. Let's see. Is there an order to this? No. Well, I guess we'll just start at the top and call this one. Label that. And then we'll label that 2. We'll start with those. Wow. Yeah, this side here has leaked for a while, apparently, before I noticed it. Something's leaked. I don't even know if coil will fix this. Oh boy. It doesn't feel good. Don't like that feeling. Twisted bolt. Twisted stud is what it really would be. That one moved a little bit, I believe. But I got to chase those threads better before I get those out. Got to do some more work on those threads before I get those. That one's gonna go. 1 out of 4 ain't bad. All right, I'm gonna take some time cleaning those threads up. Well, I got the 1 out. Tried heating this one, and even though I've filed it and heated it and everything else, that thing don't want to come out. But I did get that one out, and that element was okay, which I thought maybe that one would be bad right there. So it's time to get this one out. See if I can get this thing out of here. So far, that one looks like it's intact. Yep. That one actually isn't horrible either.
What about the gasket?
Well, the gaskets are all bad.
So you can replace them?
Yeah. No. There's 5 in here.
What would it look like if it was really bad? Just shoot up?
It'd be melted. It would be the tubes, where those tubes running around, they're a little pitted, right? But they'd be pitted really bad, and then you'd find a spot that was actually corroded right out of it. You'd be able to look inside. Yeah. Okay. It's probably from the heat. Just kept it clean whenever it was on. Mm-hmm. But I mean, I would put new ones in instead of trying to fool with that. I think this one's okay. I do have this other port, so if I can't get the bottom one out on the other side, I may end up just putting an element in there instead. Save myself the trouble, and I'd still have 5 elements. But I've got to at least get the, well, It's landslide. This isn't working too well.
Helping.
Yeah, that one's okay too. I kind of figured. So, can't really tell where the other one's at because they got little baffles in there, so I can't see if this one's any good or not, but I kind of doubt it. But if I can get these 2 bolts out, I might leave that one down there in there. Well, I got somewhere. I went and took the angle grinder, ground off the nut, and was able to get it to turn. So, yay. Get that other one. Maybe we'll succeed and run and tap on it. Might be home free, hopefully. Well, I got it. And it's actually not horrible shape. I figured that would have been melted. Maybe that one is, I don't know. But at any rate, hey, we got it. We got some success. The threads are not the greatest of looking at them, but you know what? I ran a nut on and off of them and they all work. So we're good. I guess I can go ahead and order some elements now and get these relays here and fix that wire where it melted, and I might actually have a furnace. Like I said, it lasted 10 years the first time, put new elements in, got another 10. If I can get another 10, I'll be tickled pink. All right, I'm going to order some elements and see you later. Well, I'm back working on my furnace. I got my relays in. I got my elements in. Did decide that I want to go ahead and take that out. I thought I would just leave that in there as a plug, but I don't like the gasket. Might have been leaking a little before, so I've been heating this, of course, melting that. I split that nut. I got 2 more to go, and that should do it. And I cleaned all those threads up, and believe it or not, they don't look the greatest, but they actually work perfect. So, well, if we can get these last 2 out, we'll be in good shape. So, for the best. Alright, so I try to take it right down to where you just start to see the threads. Now I've hit this one a few times. This one's really tight with electrical wires and trying to get in past those other studs, and this has been one of the harder ones. So I'm glad it wasn't one of these rear ones. That would have been impossible. Maybe a little die grinder. That's right down to the threads. The other one's cracked pretty easy, but still got some meat on it. So far, 7/16 has been working pretty good instead of 1/2 inch. And then, of course, now that I'm filming this one's giving me trouble. The other one's came pretty easy. Yeah, that stud's still trying to turn. Guess I'll take a little more off of that. There we go. I'll get this one and 1 more to go and clean up the gasket surface. We might be in business. we actually start putting it together. And I gotta get this fixed too, because it was chilly last night. Look at that. Can put it on with my bare fingers. Not bad considering we bunged the threads up a little bit with the grinder. Didn't really hurt anything. That'll be fine. All right, one more to go, and I won't bore you with that. See, even though the threads are messed up a little bit, no biggie. All right, let me get that last one off. Then we time to celebrate. So something I learned a long time ago is, well, some of the jobs that you're forced to do aren't very pleasant. You may not want to do them at the time. Like putting my tracks on the other day. Or like having to grind these tediously off and try to get the furnace fixed. I realized at an early age I had two choices. I could either learn how to do everything myself, try to save myself money and do it not only on my own, but with using whatever I had to make things do. Or I could find myself a really high paying job, probably something I would really hate doing every minute of my life, but that way I could afford to pay somebody else to do the dirty work. So it's pretty much your choice. Unless you really love what you're doing and making good money at doing it. The only other option is either do it yourself and make do. So that's probably really why I learned how to do so many different things in my life. I was forced to have to do so many different things in my life. Not a necessity. Alright. Let's see what that element. If this one's not bad, then I don't know what to do. No, I know what to do. I need it all changed anyway, but I don't know why that one burned. This wire burned. I would assume that if I took an ohm meter to these, something's bad. It has to be bad. One of them has to be bad internally. I'm just surprised externally they still look half decent. So that's okay. It was like $423, got all my elements and relays. Can fix this furnace right up. All right, clean those gasket surfaces. Start putting it together. Got all the elements back in. And all the wires back on. And like I said earlier, I was going to take that transformer and snip the end off where that bolt goes in over here. That made that so much easier. I can start the bolt, just slide that over, put that bolt in. So I got everything bolted back up, start taking the relay out. And so now all I got to do is unplug these. I just take one at a time. So basically what they have is they have a positive, negative, and they have a jumper wire to jump the, I guess I'd call it neutral really, from relay to relay to relay. So really it's not too hard to do this and get too confused. And the same with these wires here. Well, I mean there's a ton of wires, but the wires going to the up to the elements, if you trace them out, there's these two red ones. It goes to this element and that element, and they both come on the relay at the same time because they're hooked together. So in that relay, I'll show you a newer one, it's easier. So when that relay clicks in, it's just carrying continuity from here to here. So you can have two circuits. So that's why the doubled up blacks and reds. So what they have it is these two elements come on at the same time at the top. Then these two elements come on at the next relay. Then the last one, see, only has two wires back there. That's that guy over here. So that's all there is to it. So it's not too hard to cross them. I marked them, but didn't really have to. It's not too hard. Anyway, I'm going to actually crimp those because they were kind of loose whenever I went to take them off. Sorry. Get a good shot here, maybe. But anyway, I'll take and crimp those down just a little bit because they were about falling off. Yeah, it looks tighter. Anyway, go through that, change all these relays, make up a new wire, see how it works. Back here at home on my furnace, I wait till the September 23rd, first day it goes down to about 60 degrees during the day and about 50 at night, and I decided finally gonna get my furnace fixed. So let's go ahead and turn the valve back on here. Let's see what happens. So apparently there's still air in there. Okay, pushing air out. There it goes. I'm gonna get a good chunk of it out. Okay. And I think you can just put a Schrader valve on. I should be able to push that down and get some air out. Yeah. I didn't really want to get air in the upper part of the lines, but I kind of did. It does have an automatic bleeder. Okay, we're good to there. I don't know if you can just bleed that one or not. Looks high and dry so far. Don't see any leaks yet. Alright, this is about the highest point I got down here. I had a bleeder in there, so I took the bleeder out. Straight valve there. Yay. Well, that worked. Yep, that worked well. Getting things wet, but oh well. Alright, let me get that bleeder back in, and I think that's about as much as I can do right now. Now, what we can do is we can actually run the circulating pump and let that thing flow for a while before we actually turn any of the breakers on that turn heat on or anything. Well, we're pressurized. That's good. We're up to almost 30 pounds, not quite. Here, take that out. We're done with that. Louder. Let's check for leaks before we go any further. Alright, I guess I can turn the power back on. Alright, turned the thermostat wire on at the breaker box that I turned off, and I also turned on the power to the this 125 amps coming through here. I'm not going to turn the power to the relays off, but this should turn the transformer on, and it should actually make it so that I can turn the thermostat up and make it run and call for heat. I should hear one of those zone valves turn and click. The circulating pump's running, and I hear air. So we're just gonna let that circulate that system out for a while. You can hear it. Yeah, there's air. There's gonna be air in this system. I don't feel like going around all the bleeders. I've actually done it like this before, and it worked just fine last time I rebuilt it, so we'll see. We need to actually turn eventually all the zones on and let them run for a while, so I'll be back. Well, it's only been running a few minutes and it already sounds pretty good, so I'm going to go ahead and turn this down. Lisa's going to go up and turn the other one up.
No.
Let me make sure it shuts off. It ran through the cycle, all three elements. I don't know if you can tell, but all three relays, I should say. There it goes. They just shut off. So now they're in the up position. Okay, go ahead. So this back here that says Artisan, that's the timers, the timer modules. And So the one kicks on right away as soon as she'll turn that breaker. Okay, in this case, it's the middle one. The middle one just flipped on. And it's, I think, a 30 or 60 second delay. Should say on there, timer delay, 120 seconds and 60 seconds. So in 60 seconds, this other double one over here is going to click on. Let's make sure it works. You can see those contact points. I hear a little bit of water. Actually, it's the air in the water. Downstairs work pretty good. So theoretically, 2 elements are heating, although I have the breaker turned off. Probably about another 25 seconds, that thing should click on. And 2 more elements will come on. There it goes. And then in another 60 seconds, that one there will click on. And that'll be that last element that's right there. The pressure's up. Temperature's not coming up, obviously, because we don't have any of these elements turned on. Just trying to get this air so it can circulate and bleed out. Sometimes when I do this, actually, that bleeder up there on top of that tank will actually get a little damp. So far it hasn't, but I just don't like running the elements any sooner than I have to. Just make sure they don't burn up, because if they get water in them, here I go with the water again. Why do I keep saying water? If it gets air to it, air pocket, it's hard on those elements. And the other thing is you can create steam and then you get a hammer effect. Like I really should have this low pressure on. If I didn't have this, there goes the other relay. Okay. So this low water cutoff, actually, if the water got low, then you would be creating steam. That should shut off the furnace so that doesn't happen, because it'll hammer and make a lot of noise. I just got dripped on. So apparently we're getting a little, yep, I see a drip. You can see it. There's actually a drip coming out of there, so it's actually bleeding. It's working. As corroded as it looks, it's still working. Yep, there goes another drip. That's normal. So we'll just let this run for a few minutes, then we'll do the bedroom circuit, and then we should be okay. Turn on our elements. Well, all set. I'm fairly happy. Everything's been circulating and being okay. I got one little issue that part I changed. I guess I should have left it alone. Well, I tightened the jam nut and it is really slowed down. It's barely dripping. I think it'll settle in, especially my crummy water. My crummy water will probably corrode and seize up and be fine. But this guy here had been leaking, and it had actually stopped leaking all on its own. So I should have left it in there, I guess. Anyway, I think there's a seal in there because it just tightened the jam nut and it seems to help. So I don't know, I should try a little bit more. And other than that, I think I'm ready to turn on my, well, it's still pretty loose. Probably ready to turn on my elements and start trying it out. I know when it gets hot, that expands, and well, everything actually does, and then it starts working better. Okay, so let's throw on. Usually you can kind of hear them, but not real loud, but you'll usually hear some heating of the water. But it'll be a bummer if the elements don't work. Okay, it just took a little while to get the warm water, because I mean that water is cold throughout the whole system, hasn't been on, so it just took a while. It's swinging up good now. And then over here we have our high and low cutout for the relays, so it'll come on at 160 low, and then the high should kick out at about 195-ish. So we should start, we're getting there. We're 145. Although I don't remember this thing going all the way up to 190, so I'm not sure how accurate that is. But it's definitely, oh yeah, we got heat. He's cranking some heat now. Oh yeah. Alright. Well, all in all, I think we're okay. It's not getting any worse. It might be getting a little better. Let's hope. All right, I'll let this run for a while. If everything works out and everything's fine, we'll put the cover on it and we'll call it a day. And hopefully it won't freeze tonight. It was actually a little bit of bubbles coming out up there. There it goes a little bit. Yep. So now that the water is expanding, it's pushing the air out. You know, the water gets hotter. It expands. That's why this expansion tank. But all right, we're about 190. So I guess that is about accurate on that. Should be shutting off the relays pretty soon. This one over here is even bubbled just a little bit. So we got a little bit, but not too much here. That's good. All right, we're about 195. The thing should kick off any second now. Wait for it. It better. If not, we got problems. Ah, yay. Perfect. Almost hit 200, and then all the relays clicked off. So as soon as that drops down to 160, it'll kick back on again. So far so good. All right, I'm happy. Cool.